Hello, everyone. Welcome to the Kalamazoo Astronomical Society special PixInsight tutorial. My name is Richard Bell, and I'm just going to intro our host this evening. And I'm just going to make this really short so we have plenty of time to squeeze in PixInsight material. But first, I want to give a quick plug. Starting on May 21st, we're going to begin a new era in KAS history. We're going to start our very first special interest group. And of course, it's going to be about astrophotography. So many clubs around the country have various special interest groups, and it seemed the time is right for us to start our own. So again, it's going to begin on May 21st. The very first meeting, we'll talk about the schedule we'll keep. You know, what day and time of the week do we want to meet on? What will be the frequency of meetings, like once a month, once every other month, or something like that? We'll kind of leave it up to everyone to discuss at the meeting. And we can talk about topics that we would like to have, you know, potential speakers we would like to have. And of course, we'll spend some time just getting to know everyone. Many of us have probably never met. And so we'll have everyone introduce themselves, talk about, you know, themselves, their imaging preferences, and of course, the equipment they have. And we'll see who has similar equipment, and we can exchange and share ideas. So that'll be the whole point of our special interest group that again begins on May 21st. And you can go to the Kalamazoo Astronomical Society website and register for that today. But today we're going to kind of start an unofficial meeting for our special interest group here. And today we have Pete Mumbower, who's going to walk us through how to use PixInsight, which again is the premier astrophotography image processing program available today. And just a quick background for Pete. I first met Pete probably back in 1993, a very long time ago. That was back when we met above the library, you know, in the planetarium at the Kalamazoo Public Museum. And we, you know, got to know one another. And Pete and I, amongst many others, were among the ones to really give a rebirth to the Kalamazoo Astronomical Society back then, which was gradually fading away. There was a point, you know, we had like probably a dozen members. And of course, now we're pushing 230. And that rise in membership began during that era when Pete and many of us joined. And of course, I knew right away, you know, from Pete's interest that he was strongly into astrophotography. And that's part of the reason why I got into it as well. And then 20 years go by because he kind of dropped off the face of the planet. But he's now moved back into the area. And he has his own observatory he just built, which you hopefully read about in the last issue of Prime Focus. And but tonight, he'll be showing us how to process an image that I took of the Orion Nebula with the Takahashi component of the remote telescope. So he'll be processing the Lrgb images that I took with PixInsight, and I'm sure he'll tell you all about those shortly. So without further ado, Pete, take it away.
Great. Thanks, Richard. Yeah, so PixInsight is definitely, like Richard said, the premier astrophotography platform now for processing, calibrating out there. Years ago, people would, you know, process with various programs, and there are a lot out there. There's Deep Sky Stacker, you got GIMP, there's Photoshop, you name it. There's a lot of packages out there, but as people get further and further into astrophotography, PixInsight really does do it all now, and that's good and bad. There's a lot to it. It can be very complex. It can be very easy too. So I'm going to keep it really simple today as much as possible. An Lrgb can be kind of complex. I mean, there's obviously multiple things going on. So I hear a dog. Is that my dog? Uh-oh.
That's my dog. This is Dale Mace.
Oh. Whoops. So anyway, sorry. So so we're going to be focusing on Lrgb. And the primary tool that we're going to use for, we're going to start off with calibrating. Originally with PixInsight, you would actually go through and manually calibrate it. And if with CCD images to calibrate, you would take your light frame and you would subtract your dark frame. You would divide it by your flat field, and you would get your processed. And then you would, you know, combine them all. You know, you would stack them, and then you would have your, you know, finished product. And that's very laborious. There's a lot of work doing in there. Nowadays, they have a really neat script they have that's called the weighted batch process, WBPP, weighted batch processing. They make it super simple for people to do that. And basically what you do is you load up your stuff. You collect all your dark frames together. So for instance here, Richard provided them all here. He zipped them. It took a long time to download them. These are, like I said, is from the club's remote telescope, so they're pretty big files. So what I did is I loaded them all up. So we took all the 600-second exposures. You click open, we put them in there. We got our flat fields. You add your flat fields here. Look at your flats. There's the luminance. We add the flats. There's all the luminance for the flats. Oops. Flat fields are right there. Darks, flats, lights. And then the lights. And then you add them in here. And if anywhere along here, anyone has any questions, feel free just to jump in. I'm just going to kind of be going across here. So like I said, with PixInsight, they make it real easy to handle the calibration, because I think a lot of people get stumbled in the calibration portion of it, and they do make it really easy. You collect your lights at your telescope, obviously at night. You know, you got to get your, obviously, all your guiding and all that stuff. And it doesn't have to be guided. I mean, if you're doing, you know, with a tripod and you're doing super short exposures, or you're doing piggyback, you know, or prime focus or whatever, you get your lights, you collect your darks. If you're doing flat fields, great. You don't have to have flats. You don't have to have bias frames. In here, actually, right, Richard did do bias frames too, so we are going to collect those. Where are they? Bias. There we go. Pick them all. So and then you can look. Okay, you got bar, you know, all this stuff. The nice thing with this is they have a control panel, so you can actually look in here and say, hey, they got green check marks, so you can check and say, does everything have everything? Does your light frame have all the stuff that you need? Does it have the various stuff? So is there bias frames? Is there dark frames? You can see all the various information. You know, the flats, are they there? Is the dark frames there? Do the flats have the bias and the darks? Because your flat frames should have a dark frame, you know, to subtract it out. Technically, they are super short. They're 0.21 seconds. So technically, there's not enough dark signal in there. You could just use a bias frame. If they're long, go ahead.
The weighted batch processing script, where's that dropping down from? Is that from the process?
Yes. Oh, no, it's actually from the scripts. So I'm not actually going to run it, because when I ran it on my system, it took a while. So I've already pre-run this.
That's under scripts. Okay, thank you.
Yeah, if you go under scripts, when you actually look under scripts, you're going to see one that says batch pre-process. It's there for in case you had something from before, and they'll pop a little warning saying, hey, don't use this, use the weighted one. So anyway, so yeah, so you basically, you have all your buttons at the bottom, weighted, you know, your bias, your darks, your flats, your lights, and you just add them all in there. If you don't have bias, you can get by. You really do need your darks and your lights. They really do help. You technically could just load your lights and see what happens. You won't get the best results, but you know, having flats in the darks, that does help. You do get your best results. Now, the other stuff, you want to put an output directory so you know where everything is going to go. And when it does generate the stuff, file structure, just a quick little thing, side note here, you kind of want to organize, obviously, where things are going. I have a directory structure that I have for batch, I call it BPP. I should actually call it WPP now. But you can see I shoot with narrowband, so I have my S2 filters, my red. When I shoot one-shot color, when I shoot RGB, when I have my RGB, when I do my RGB filters, I'll throw all my RGB in here all at once. So wherever I'm going to say this is all luminance, I'll just pick the filter. I pick luminance and I throw it in there. It's going to generate all the various folders for you. So that's important to set up. Registered reference images. If you're going to have this actually align your pictures for you, auto check this. So what that's going to do means is this script is actually going to, when it actually calibrates and does everything, it's going to go through the entire stack and pick out which is the best frame. And it's going to say, yep, this is the best one to align all the other subframes. And then it'll do that for you. And then it'll align them for you. And then with the image integration below that, it'll actually do the stacking for you automatically. And then the subframe weighting, what that means is it'll also actually look at all of them and say, well, which one is actually the best of the best, not just which one is which one's going to be the best for alignment, but which one has the best signal to noise ratio, which one's going to have all the various statistics. Basically, this is an automation script. You could do all this stuff manually if you wanted to. For a lot of people like to get their hands dirty, lift the hood up, do all the stuff manually, and sometimes you do get slightly better results. But I found using this script, you get about 90% of the way there. Very rarely do I actually want to not use this script to actually do it myself. Now you can do things. Sometimes if you don't have a ton of frames, maybe you have 5 frames, your image integration, you don't get all the options. So you can click that and say, do you want to do average or median? What type? Usually the defaults are good. Usually what you have problems with is your linear fit clipping. Hey, what's that? You can hover over these. And what that means is, if you look in here, it'll tell you, hey, this is good for over 15 frames. So if you have over 15 frames, this is going to be really good. But if you had less, they would say, hey, you might want to use a Sigma clipping or maybe something different. Winsorized Sigma clipping is actually a pretty good one. I use that one a lot. So you can go in there. Maybe you have a lot of satellite issues. I know Richard pointed them out. I actually gave him a preview and we kind of played around with some stuff. And he said, oh, there are some satellite things. Well, you could actually go back in here and rerun it, and you could pull your high down a little bit, and that'll be a little more aggressive with your rejection. And you start tweaking it down, and all of a sudden your satellites disappear. Sometimes you'll get some of that stuff. So sometimes you do go back and you can kind of tweak things. There's a lot of stuff you can do. Large scale. So generally, there's a reset button. You want to be careful of that button. That doesn't reset like what you're looking at. It resets everything. So anyway, the default settings generally do work very well with these. The biggest thing you would probably do, for instance, there's this diagnostics. If you click this, it'll say, hey, for instance, here it says, let's see what's this saying. Linear fit clipping may not be better than Winsorized Sigma. This will give you some suggestions for stuff to do, which you can kind of play around with it. Generally, if we ran this as linear fit clipping, and then you turn around and ran it as Windsor Sigma clipping, and you looked at the 2 results, I guarantee you most everyone, myself included, or even some of the pros, they would have a hard time telling what the difference is between the two. Maybe if they analyzed it and said, what are the mathematical differences, you would probably see the difference, but it's, flip a coin, you can kind of tell the difference. Yeah.
I have a question. This is Chris Miller.
Yeah, go ahead.
Does this provide a way to save? I mean, you've selected all your lights, flats, and darks. And your settings. Does it provide a way that you can save this setup? I mean, to know once you get the results, oh yeah, how many light frames did I have in this result set?
Yeah, when you
Sky Stacker provides that, you know, it generates a text file of all the inputs to
the
model.
What you can do here is this little guy right here. You drag this thing off. Oops. I drag this corner off, and now you have a little process thing. So right now it's kind of beeping at me. But I dragged this off, and so this is a copy of everything that was in here, this whole entire setting right now.
Oh, okay. And
so,
then, yeah, so there's an ability to save the process model. Yeah.
Yeah, so you can process it off. And actually, when you actually run it, when it's done, it'll have the complete results, and you can actually, it has a save button, so you can actually save it, and it'll give you the results, including what you did, what the results were. It also tells you, like, for instance, what was the best frame that you had? It'll actually tell you, and that's important to have, because like when you're doing Lrgb, when I was doing this one, I only processed the luminance separately because I wasn't sure exactly what the data looked like. So I ran the luminance first just to see what was going on, because there was, 600 second, there was 300 second, and there was 30 second. So I ran the luminance 600 first. I found out what the best one was. So I saved that. So in subsequent, all the rest of them, I knew which one, actually, if I pull this over, this was the exact one that was the best registration. So I actually unchecked this one, and whoops, I lost it now. So I popped this into here. So all the other batch processing scripts I ran, I used this file right here, this whole entire path actually. I popped that in there. So all the other ones I ran for red, green, blue, and then the other luminances that were shorter, they all were aligned into the right spots. So once I actually did the, the combining and stuff, it all worked out. So we'll see that here shortly.
Okay, thank you.
Yep. Mm-hmm. So yeah. So anyway, so where are we here? So yeah, so image immigration, average is usually pretty common. Most of the time you'll use that. Median, a lot you can talk about, image integration theory. Registration, same thing. Sometimes people have problems with, things aren't aligning. Sometimes it will spit out saying, hey, it could not align stuff. Sometimes you might have some issues. Sometimes you have to crank up your noise reduction. That'll help clean up, it'll help it detect images. There's stuff that you could do with these settings. If you are having problems, shoot me an email or get a hold of me. There's a lot of things you can kind of tweak here. Or if you are having problems, sometimes you just can't do batch pre-processing. You got to do it the manual way. This stuff, the subframe weighting, this gets interesting. You can say, hey, what do you want to prioritize stuff? There's a module, we'll get out of this real quick, that's called, I don't know if anyone's heard of it, probably have. It is called Subframe Selector. I use this a lot. Sometimes I'll run, oh, actually, let me shoot this back up. One thing you can do, like I said, this is really good for, dealing with, how exactly do you do your calibration? Because you have to, like, calibrate your lights. So you have to get your darks, your flats, and all that stuff. And if you're using biases, well, what exactly are you subtract your bias from your darks. You got to do all this other stuff. Well, one thing you can do that I do quite a bit is, where are they? Excuse me. If you uncheck the apply stuff, what this will do is this will actually just calibrate all your data for you. And then, or actually you can just do everything. You can just hit image immigration if you want. Or just do this and it'll just do all the calibration. And then you can do the actual stuff that actually could make a difference for your stuff, which I find handy. I'll do that quite a bit. So you could go into Subframe Selector, for instance, load up all the stuff that was calibrated for you. And then you can put in some basic information. You take all your calibrated stuff, you add your files. So you put all your stuff in there. You put in your image scale. So that's what your camera's actually seeing. So for me, for my camera, for my scope, it's like, let me see here. Where is it real quick? Oops, nope, that's not it. .684 is mine. My camera gain, it's 1.374. Camera gain, if you don't know that, usually the manufacturer publishes it. If you really want to know what it is, sometimes the camera manufacturers aren't totally super accurate. PixInsight has a really cool tool. It's a script that calculates it. You just need like 2 dark frames, a couple flat fields, and that's all you need. You put your resolution in. I have a 16. You can measure it. And what it does is it gives you all the statistics. You get the full width half maximum, the eccentricity, all this neat stuff. Really what matters is like some of, you could, eccentricity, that's how oval is it from round to an oval. When you're looking at an astrophoto, it's pretty much been agreed upon that if you're over like 0.5, your eye can see that it's an oval. So generally you can make a, you just kind of look at them, you have these subframe tool selectors. I'm just trying to think of a way to do this real quick. I'll just add some of mine real quick. Lumens. Okay, I'm going to calculate some from some of my luminance from NGC. It's a Hickson 44. It's a group. Now, there's a quick question while this is processing. How many people here actually do use PixInsight? Is there, actually there's no hands on here, but.
I'm on.
Okay. So we got a few people.
Dave.
I just got my trial copy a couple days ago, but I know nothing about it at this point.
Okay. Okay, good. Okay, good. So like for people who just got it or just getting into it, like I said, that weighted bat, the WBPP is a really good tool. And if you have a one-shot color or monochrome chroma, that's the way to go. Definitely. The manual calibration stuff, it's great. There's some really good books out there. Okay, so here it is. It's all stuff. So you can see I got 0.4, which is good. Yay. You can sort stuff. So I can say, what's the worst? 0.564. Okay, that's not all that great. Yeah. So here's a tool. There's a calculation. Okay, what's your friend in Notepad? I have all these stuff that's really good. I keep notes like my image scale for my camera at 1:1, my camera gain. I have this weighting scale. So this weighting scale, it's a calculation. So I want to know what's the best frames. And I actually got this off of actually one of the PixInsight forums. Is guys that know way more about this stuff and math. And what this does actually is, oops, sorry. Oops, descending. So what this does is it takes into consideration the full width half maximum, how sharp your picture is basically for stars, the eccentricity, so how round your stars are, and the signal to noise ratio. So really kind of like, how, how good your image is, basically the noise and all that jazz. So this image right here, frame number 27 for me, was my best image, I guess. Oops, I made a mess of this now. So, and what you can do with this is you write it out, and when you write it out, it's going to take this value, and you give it a directory, and it's going to put a keyword into the file. And then what you can do, I'll show you later on, is it helps that when you do the stacking, you're going to say, hey, this file has the most importance when it's stacking, and this one has the least, I don't say the least, but it's, it's not as important. This one has the best using this formula. So this subframe selector is, is really a powerful tool to use. And it's, I'm just going to get out of this real quick. In this tool, the weighted batch processing does include that, and that's right here, and it does it automatically for you. So as you're learning, when you're beginning to use, PixInsight, this can handle it. And as you get more comfortable with it, you start to think, well, I'd like to kind of see how things are going myself, or maybe you want to say, well, maybe some of my frames aren't the best. You can use that subframe selector and say, okay, yeah, maybe I want to use the best of the best. Maybe you're trying to go for a real small planetary and all that stuff. So anyway, okay, so we're going to move on now. Okay, we've talked enough about, your calibration, and we got the data. It's all aligned. What I did is I ran this tool against all the data. And so I'm going to open this all up. Does everyone have any questions about weighted batch pre-processing, anything along those lines? Flat frames, you name it, anything along those? No one? Okay. There's this tool. This tells you all the, by the way, if you pull this up, this will have all the stuff in there about this stuff, and then you can reapply this back into that tool. So I'm going to go back to Richard's data. So open these up. Nope, that's not it. Okay. So masters, we're going to start with one of these. So when you actually crunches, you get 3 files out, for instance, and it depends. Sometimes when you run a linear fit, you get some things. Sometimes when you run, depends on which one you get different things. Sometimes you get things called slope, high rejection, low rejection. This is a high rejection. This is the stack of all those 16. There was like 16 600 seconds. Quick side note, over here, top right, this is called the screen transfer function. Basically, this data is the raw linear data. It has not been touched yet. So this is like, nothing's been modified. We haven't done nothing to it. And if you look at the histogram, this very first one, actually, let me back up one second. This is all the stuff that has been rejected by this stuff. So the Orion Nebula, it sits right where all the geostationary satellite. This is the bane of Richard's existence around the Orion Nebula. Look at how many satellites there are. I don't know how many there are. There is a lot. So Richard, the rejection does work. I don't know how many there are, but there was a lot. I don't even know what all these dots are. There's little dots everywhere. There's a satellite. There's one. So you got a lot of them. So this is all high stuff. So what this means is on every frame, what you're seeing is the algorithm said, hey, compared to most of them, there were pixels that were higher than others. So we're going to reject them. And this thing is like keeping tabs of it. And after a while, it just keeps tabs. And it's just like a record keeping. It says, okay, yeah. So this is like, this is, so you just close it off. And it's just more for record keeping. This is all like low data. It's just more like, it's nice. Okay. So this is the actual main show. This is what we're interested in. And if you look in here, this is your histogram. This is kind of tells you like, hey, this is what the data looks like. So right now, if you look in here, here's your bar. There's nothing here. This is the whole entire, this is it's a 16-bit camera. So it's 0 to 65,000 something, 534 or whatever. So your screen transfer function, so it's in the processes, screen transfer function under S, screen transfer function right here. This is your friend. Your histogram transformation is your friend. This is going to show you like reality. This is what you want to see. And you want to have this one. 2 buttons, this lower right corner, this is the reset. This will bring everything back to whatever the tool you're using. Every tool pretty much has it. This little lower right corner. Very useful, very useful. In the screen transfer function, there's the little nuclear button. I don't know why they have it as a nuclear button. That's what I call it. But this is going to auto stretch it. This is going to show you the potential for whatever you're looking at right now. So we're going to hit it. And so for the 600-second exposure, that's 600 seconds, which is 10 minutes, and he's got 16 of them. So we got, I don't know, whatever 16 times 10 minutes is, a lot. So we got some good data here. We got a lot of background nebulosity. Obviously, it's the Orion Nebula. We got the Running Man Nebula down here, and we got all sorts of cool stuff going on in here. We can zoom in. It's really clean data. If you look at it, there's really not a lot of noise. It's actually pretty good. You look down, oops, wrong way. You kind of want to scroll around, look around. If you look at the stacking, notice how remember where all the, I should have kept the other ones open, but remember where all the satellites were going through? They're all gone. Not one satellite. Richard, do you see any satellites? No. So we know this is good. There's not in here. So the stacking did a really good job for these 600 millimeters. So I know there's a lot of concern with astronomers, especially like with this, you know, the SpaceX launching all the
Starlink.
Yeah, Starlink. I have done hundreds and hundreds of hours now, ever since they've launched those suckers. I have yet to have any of my astro images. Now, for the professionals who are doing like the large symphonic, the new one, the one down in South America.
Sky survey.
Yeah, that one will have issues, I know, because of the exposure times and the size and all that kind of stuff. But for amateurs with modern stacking techniques like this, we'll be able to manage, I think. It's still a concern. I mean, obviously, you don't want to see them flying all over the place and all that stuff. But with stacking techniques, it does work pretty well. So anyway, so now this does look really good. There are issues, even though it was taken from beautiful Arizona dark skies, there is some stuff going on in there. This was flat fielded. There is a right to left gradient to some extent. The right side is a little, there's something going on. I don't know what it is, but there is something light, and it's not just dust on the right side and something going on the left side. I can just see it. So what we need to do, and usually what's typical for a workflow, is to do a what's called a background modelization. You want to, in PixInsight, there's 2 tools. It's called dynamic background extraction, or ABE, or automatic background extraction. They're up here. Generally, let's do a quick thing. There's a thing here called processes, and you can actually look here, and they do a pretty good job now of like, hey, what's, you know, background modelization. So these are the 2 we're looking at. So, and they kind of do a good job of breaking it down as far as, you know, channel combining, color calibration, deconvolution. That's a common one that people, you know, will understand right away. You know, deconvolution is a popular one. You know, fast rotation. So obviously that's rotating it various ways, you know, rotation. Dynamic cropping, that's a tool that you can use to, hey, I want to do a quick crop. Well, we don't want to do that though, but so you can access a lot of stuff through here. Noise reduction is a popular thing area. Some of these things, you know, pre-processing, like I was talking about, you can do your star alignment, image integration, which is the stacking. You have image calibration, which is your manual, subtract your dark frame, you do your flat fielding, all that kind of stuff happens there, so on and so forth. Or you can hit all processes and it shows everything you can possibly do practically from a process point of view. And then I know someone had mentioned scripts. People can actually write stuff. If you know how to program and stuff, you can actually go to the PixInsight's website and they actually have, what languages they use. I believe it's all in C#, C+, or whatever, a Microsoft language. You can contribute to their, programming base. They had really cool tools.
Yeah, I got a question.
Yeah.
If I have a lot of data that was taken and stacked in Maxim, what kind of files can PixInsight handle? Does it all have to be TIFF?
What kind?
Does it all have to be TIFF like Photoshop?
Well, you can pull in a lot of different file formats. I mean, JPEGs.
It will handle JPEG. Okay, good.
Oh yeah, JPEG, bitmaps.
Because Photoshop will not.
Oh yeah, Photoshop won't. Yeah, Photoshop. This can pull in pretty much anything under.
No, it can't. They want it all in TIFF.
Oh,
out of Maxim.
Oh, out of Maxim.
Yeah.
Yeah, anything. Yeah, this software can pull in. It can pull in FITs, TIFFs, JPEGs, you name it. Icon files.
Thank you.
Yep. So yeah, this can handle pretty much anything. So anyway, yeah. So there's a lot of things you can do. Obviously, there's the FITs headers, so you can go in here. Hey, this is the observer, Richard Bell. Where was it taken? You can add stuff in here. PixInsight actually does a good job of writing everything that's happened. What's going on in here. You can add stuff in here. If you're into photometry or doing any other information, it does have some stuff in there for that. Or astrometria is in here. There's some tools for that. So there's a lot of stuff you can do. This is a sidebar for FITs, headers, and stuff. So anyway, let's see here. So ABE. So that's the next thing. So what we're going to do, like I said, we have a gradient going on here, and it's really basic. I mean, it's really, looking at it, it's like a right to left one here. Now, there's two ways we can go about dealing with this. I guess my kind of general rule of thumb is try to keep it as simple as possible with image processing. When I first started doing this, I mean, I've read the books. I mean, Warren Keller makes an excellent book. It's called, where's my book? I don't know what it's called. It's PixInsight Processing, I believe it's called.
Inside PixInsight.
Yes, that's it. Excellent book. It's slightly out. I don't know if he's had an updated version because PixInsight is constantly being updated, but it does cover a lot of the core stuff. Excellent book. He has an online video, like a video series that you can pay for. Adam Block has a great online, a PACE part. He has a PACE series. It's kind of pricey. But he also has a lot of free content too that covers basics. He has a YouTube channel. There's a lot of free content out there if you want to dig around. That's the hard part. There's a lot of people that do have free stuff too. So sometimes it's like digging through stuff and trying to find stuff. But what I found is if you keep it simple, you generally get good results. But sometimes, like with PixInsight, like I said, it can be complex. So I try to keep dynamic background extract. This is a powerful tool, the most powerful tool for like fixing things. What it does is if you don't have a flat field, whether it's this tool or the ABE tool, it'll help take care of light pollution. It'll take care of flat field issues, if you know how to use it properly. You can get really bad results. You can get awesome results. It can go both ways. So for here, what you want to do is there's two things you got to struggle with it's like, for instance, we got the crosshairs here. What we do is you start putting samples around. You can see they're starting to go red and stuff. And what you're doing is you're sampling the background. What you're doing is you're going to tell the tool to say, hey, ideally what you want to put your little samples on the blackness of space, not on dust. You want it on the blackness of space to say, hey, you know, this is what the background is going to be black, you know, space. You know, if there's light pollution there, or maybe there's vignetting issues, you're saying this should be a neutral background. This is what, whatever, works. Sometimes it's not possible. This type of image is very challenging when you have all sorts of stuff going on in the background. You have dust going on. So it gets challenging, because if you place something on a dust, well, the tool doesn't know it's dust. It knows it's that you placed it there. And so it's going to assume that, hey, that's the background. So it's going to go out the door with the rest of it too. So it can be challenging. So where you put these things gets really, really tough. And when you have a crowded star field, it gets even more challenging, because you can't have, you really can't have this sit on top of stars. So what I like to do before I go to the DBE tool, I go, you know what? DBE is really powerful and it's great to use. But sometimes, hey, let's try ABE to see if that works. Because if it can work, let's try that. So that's what we're going to try here. So always rule number one, try tools with their default setting, because usually the guys who make these tools, they usually set the default settings. They tend to work pretty good sometimes, for the most part, right off the bat. So let me try that. So I'm just going to open up the boxes. So your correction, we're not going to do any corrections yet. So subtraction, what this means is it's going to, we're not going to do anything really. So what we're going to do is we're just going to throw this on and see what happens. What it's going to do is it's going to make a background of the model, and we can't see anything, obviously. We're going to check it and see what happens. Hey, is this what we think's happening here? Well, no, I don't think so, because I know we did a flat field, because actually, and I can tell you that, because if I open this up, we can go back to Richard's flats. Where are we at? 740. Oh man, I gotta start speeding this thing up. So Richard did a flat field, and he did a good job at a flat field. So I know this is not a flat field issue, and I already knew that going in here. So this isn't the right kind of a correction. I want a flat one. And the problem here is this degree function. Degree functions try to do complex modeling, so it's too complex. You crank it down to 1. So when we do this, it's going to give us a, do this real quick, a nice right to left. And that's what we have here. And that's what I was saying here. I saw something here. I can tell this side's dark, this side's light. That's just what the issue is. So what we want to do here is do a subtraction. We're going to toss it on there.
So Pete, I have a question if you can.
Yeah, go ahead.
You're when you're shooting your Lrgb, you're shooting all four different channels.
Yep.
Are you processing each channel separately?
Yes.
Okay, so when you do that, do you need to keep track of what you do with each channel, or are you just kind of like winging it with each channel and then, throw everything together?
Yeah. So like with the luminance, you process the luminance separately. You will process the red, the green, and the blue separately. Yeah, you will do that. But it'll all come together. So one thing you can, sometimes you can, because I mean, I'm going to quickly kind of start cranking through some of this part of it. But like when you use the not this tool, but the other tool, once you place the sample, say on the luminance one, you can actually use this little thing right here and save it and say, okay, I got the settings for the luminance good. That's going to work pretty much for all the images, because your optical settings are going to be pretty much the same. You're shooting from the same, assuming that you're shooting from the same place. So now I can say, okay, bring up all of them. I'm just going to start tossing this onto all of them. And you can do that. So that would help speed it up. because I can see here that, yeah, this did a really good job of correcting this. This looks really well corrected at this point. Does that make sense?
Yeah, I just want to know if you're, if you're kind of following the same workflow and process for each channel to get more exact results. Thank you.
Yeah, yep, definitely following the exact same, almost pretty much the exact same results, pretty much getting up to a point. I mean, like with luminance, I definitely get up to a point where I will, especially going through like up to here. Once I get to the automatic once I do this part where I get the calibrated and I get this background extraction, it starts to get a little bit different, because with Lrgb, you're doing, your luminance is really like is what's contributing all the, like the sharpness, a lot of the background data. I mean, this is where all the action's happening. It's going to provide a lot of the depth. The RGB part's just adding the color stuff. So you're not going to go your exposures are typically not as long. It's just providing the color data. So you're going to focus on like deconvolution, a lot of the sharpening, like for instance, with this, with the luminance, you will see here. I'm going to shoot this over here real quick. I'm going to open up all the, go back here. I have all the luminance already. Okay. So here's all the, I already ran everything through the ABE filter already. So we got our 600 seconds, we got 30 seconds of, we got 300 seconds, we got 600 seconds of green, we got 600 seconds of blue. Oh wait, green, blue, wait a minute, we need red. Oh, there's red. Whew. I was getting really worried there. Man, that would have been the worst tutorial ever if I didn't have the red. Okay, so now this is unique because we got a HDR. This is a little different because it's the Orion Nebula, and hey, we got a lot of dynamic range. So what we got to do here is we got to deal with a large dynamic range. So we're going to use the dynamic range tool. So it's called HDR Comp. Right here. This is a real easy tool to use, because what we want to do is we want to deal with the Orion Nebula. We want the outer stuff, we want the faint background, but we also want as much as the core as possible. So and remember, this is just the luminance. We want the luminance we're going to spend a lot of time here. So typically, let me see here. I am going to, nope, not there. I need to open up. So with this tool, this is easy. It's a great tool, HDR composition. This handles dynamic ranges that are large. You put your longest exposure at the top and then start working your way down to your shortest. You could have 50 in here if you really wanted to and you wanted to spend a long time running this, but that's all you have to do. Default settings work really good on this one, and then we just hit go. Just got to wait for it.
Does that have the effect of weighting them, kind of like you do in the DSLR, the mirrorless world, and you have plus or minus 2 or plus or minus 3, things like that?
Yeah, it's going to start like masking it down into the, it's going to start looking at the dynamic range and start masking it down into the core for you. It's going to start start compressing the dynamic range. So it's going to look at from the background, and it's already done. Hey, I got a fast computer today. So I'm just going to close that off. So I'm just going to do a quick stretch. Now it doesn't look like it. Hey, what happened here? It's still kind of blown out. It's not really. So I'm just going to close this real quick. There's 2 parts of this tool. Now, part 2 of this tool is HDR Multi-Scale. Whoops. Dink. Why am I not seeing it? HDR.
Are you looking for HDR Multi-Scale Transform?
Yeah, my brain is
I was going to say it's at the bottom.
Yeah, I was looking at the wrong one. Sorry. So, okay. Now, multi-scale transformation. This is where, like I said, one thing you can do, obviously, if you're new to PixInsight, you got to play around with settings, sadly. I don't say sadly, it's part of the fun. What I like to do is, if you see here, this thing that says HDR on the side, you can make a copy. Because you're not going to know what the best setting is right off the bat. You might say, this starts off at 6. I'm going to reset it. Is 6 going to be the best setting? Is it going to be 7? Is it going to be 10? I don't know. We don't know yet. So I'm just going to throw 6 on here. We're going to see what this is going to do. It's going to stretch this for us. It's going to go in there and do all sorts of crazy things. And it's going to allow us to see the true dynamic range of this from the brightest to the darkest part of this image. Oh, you know what? I totally forgot. Oh, I failed. I'm thinking a million miles because this is like one of my first. What the problem is we're looking at this as a linear image, guys. We're only looking at this as a screen transfer function. So if we look here, hey, this is all black. Why is it all black? Because we're using the screen transfer function. If we look at this from the HDR, there's nothing here. It's all black. So what we want to do is, this is a good starting point. The screen transfer function gives you a really good point. So your screen transfer or your histogram transformation says, yeah, this is not stretched yet. So what you do is this, you hit your little button here. You just take your thing here and you drag it down to the bottom gray bar, and it shows you how to stretch it. And then you can hit that, say, hey, what's going on? Now you take this, and boom. Now you're stretched out. And you do the same thing here. Oops. Stretch that. Go to here. And then, oops. Oh, did I just mess it up? Yeah, there we go. So, okay. So now, both of these, you click this now. If you hit your reset on the screen transfer, you say this stays this way. So if I were to actually like do a save as and do a file save as a JPEG, this is what you would see. If a few minutes ago I did a file and a save as and you sent it off to a friend or did it to Facebook, you just have black and you'd be, hey, what happened? It looks so good because you hadn't stretched it yet. So anyway, so HDR transformation, do it again. Sorry. Okay, so now look at this. It compressed it down. Now we're starting to see intricate details in here. We can zoom in a little bit. So we're doing a lot better. This is what it was, and this is what it got into. It's still blown out, and that's the problem with Takahashi and a super sensitive camera. Even 30 seconds, you're still blown out. I wish I could fix that. You need like even... There's two ways around this. We could do a use the 20-inch telescope and like blend it in, or do like 1 second exposures. I mean, there's a few ways, but for now, for the sake of everything else, we're going to leave it as is. But we're going to play around with this other side and say, hey, you know, what's 7 look at? We'll take a look at 7. Let's see if that's any better. I know the answer because I messed around with this for days.
Pete, it's Mike again. Do they have a subtraction stage at this point, or like a layer?
As far to like deal like with just the core area?
Yeah.
Yeah, you could. There's a thing called pixel math, geometry. Nope, not there. Yeah, where's pixel math? It is.
How about pixel math?
Yeah, it's called it's called pixel math. You could do that under pixel math and actually you would like use the 20-inch data. You'd have to do the it would take some pre-work to get it ready because you have to get it down to the right scale so it actually fits into the frame.
Oh, okay. But
then you could do it. It's not like super quick, but anyway. So this is what 7 would look like. I mean, it really starts becoming like personal preferences. And I know me and Richard kind of talked about it toward the end when I started sending them. We started going back and forth on different renditions of this. It starts becoming like, you know, artistic renditions of, like which version do you like better? You can really crank these things up. Nice thing with this is you can always hit, obviously like every other thing you can do undos, redos, and all that kind of stuff. For the sake of this tutorial, I'm just gonna close this off and say, hey, we're gonna stick with this for right now, and we're just gonna move on to the RGB for right now. So for RGB, let me think here. Yeah, so we need to get some RGB going here. So we need some color to happen. So to do that, we have, you got your R. Oh, some satellites got through here. So this would be a case where, once you got your stack out, you would look here and say, oh, there are some satellites. You would go back to your stacking and actually tweak that one slider bar. Remember, if you guys remember right, I would just tweak it down a little bit, like, 0.1 or whatever, rerun it. Oh, they're gone or not gone. Tweak it down a little more. Anyway, so to get the color part now, what we want to do, if we can close this, is go to process. If you go to color, if I can find it again, color spaces, color combination. I'm trying to use the menu. Usually as you use your tools, your most used tools show up in here. Sorry. Your most used tools show up in here, but you can also access them up here. So what you want to do is your color space, typically you're always going to use RGB, so you have it checked there. And then we're combining RGB here. So we're just going to click on here and we just got to pick your colors out. So since we're AB, you're going to find them in here. So there's our red, hit OK. We're going to click here. We're going to pick our green. That's OK. And then we're going to pick our blue. Yeah, did good. And then we're going to hit the round one. That's our global. And then we can close it and say, hey, there's a little bit. Remember, this is linear, so this is like straight out. This is what it looks like. We're going to do our screen transfer function and see what it looks like. Ah, what happened? It looks all red, looks all funky. With a screen transfer function, you can see there's like a little link thing. These means all the channels are linked. It's all one-to-one. This is like, there's no, color balance, like auto color balancing. I guess Photoshop and other color tools have it. This is how, like, straight up, this is how it looks, without the color adjustments. If you want to say, so that means we need to do color calibration, and I'll show you that tool. But if you want to say, hey, what's this going to look like? Roughly, what does it look like? You can unlock it and hit it again. You can say, oh, okay. Hey, yeah, we got some good color data here. We got some red background. There's some blue going on. It looks like the Orion Nebula. But it will get better because this is not totally accurate. This is PixInsight doing its best guess of what's going on based off of.
What did you do to unlock it?
There's in this top left here on here. There's like a little. Oh. There's that little gear, or I don't know, gears, a little chain link. Yeah, the little links. Yep, just hit that. So you hit there, unlink it, in there. That's all you got to do, and that'll guaranteed fix it. A lot of times, people with color cameras, first time they'll go, "Hey, what's going on?" Or any type of camera. If you unlink it, that'll guaranteed make it look pretty good, especially with anything like that. But we want to color calibrate it. So what we're going to do is use the best color calibration they have ever come up with. This is really cool. It's called, in the old days, you would use background neutralization, which you would actually put a little rectangular box and say, hey, this is devoid of nebula and galaxies, and it would do its thing. And then you would actually do a color calibration where you either put it over a galaxy, because galaxies are broadband. It's generally accepted that they're white objects because they're the sum of everything coming out of a galaxy. Or you would actually do a mask, a star mask, and say the sum of all stars is white because you're looking at the average of all stars. It'd be white. Well, that's a lot of tedious work too to do all that stuff. And so what they did is they came up with a photometric way of basically doing that for you. And it's called the photometric color calibration, which is really cool. Now, the only thing you got to do is you got to input your right ascension and declination so it can plate solve this for you. You can do one or two ways. You can do a search coordinates, which I've had hit or miss results. You can just click that in and type the object name and do all that stuff. But since we have a scope that has a fits header and all that fun stuff, what I'm just going to do real quick here. Let's open up here. You just bring in one of your raw images and you hit acquire from image. And it says, hey, I just pulled in all the data, and you can see it populated the right ascension and declination for you. And we're just going to minimize this for us. And then pretty much everything can stay as default. You're going to have it neutralize the background for us. It's going to search a catalog. There is some setup you got to do ahead of time with this tool. They have some really good, basically you download a star catalog onto your hard drive. They're free. I downloaded the biggest ones that you could possibly get. But there's small ones. They have really good instructions on how to do it. Your working mode. We're doing broadband. This is what we are. You could do narrowband. That's an option. Your white reference. The default is fine. There's a lot of things you could do. I mean, you can do all sorts of stuff. You can base it off of stars, different types of galaxies. The average spiral galaxy works really well. So we're going to take the little triangle here, just drag it and drop it on our image to say, hey, we're doing this image. And now we're going to wait for it to, what it's doing now, if you look here, it's plate solving this image for us. Fortunately, it's not super long. It's using the GIA star database. That's the big one I pulled down. And it's going to plate solve it, and it's going to do a fit of all the stars in here. And we're going to get a cool graph. It's going to show you how well it matched the first star colors, you know, yeah, we'll see here in a second. Yeah.
Pete, have you heard of Calibrator?
Yes, I have.
Is that similar to this?
Very similar, except this is built into PixInsight.
Right.
Yeah. So with the Calibrator, you basically, yeah, you do the same thing, but outside. And then you bring the results in, or yeah, I started messing around with it a little bit, but like I said, you kind of do it outside, but this works right inside. Like I said, you can download, there's a couple catalog choices you can pick from. Actually, when this gets done, I can drop down the little the photometry catalog drop down list so you can tell which one. And I have it limited to 12th magnitude right now, but I have never had issues. Even off in the realm of galaxies up in Leo, where I've been working this past spring, I haven't had any issues, even with the little field of view I have lately. I actually heard my plate solving right now, the GIA DR2. Oh, finished processing without errors. Hey, that's a good sign. Oh, no, wait, still thinking. 1,783 stars. $810. We're doing good. We're almost toward the end. Hanging in there, guys. How's everyone doing? Any questions? Now, with like, we're already into the color spots. A lot of times with like galaxies and stuff, one spot I skipped over with this image is deconvolution. I do deconvolution a lot. I do like that tool. I'll do it right after doing the DBE or ABE tool. Or actually even, yeah, right after that, I'll do that tool quite a bit. And to do that, you go around, you pick your stars for a sample image. And with the SIG group, that could almost be a subject, just how to use that tool alone. It's a really good job of helping reduce your star size, bring a little bit of detail out. It's a really neat tool to use. I do like that one. I need a faster computer, I guess. Oh, here we go. Hey, something's happening. Okay, so you can see these are all the greens are all the stars that got fitted. So I actually got a really good fit this line. All the stars match up. We got white balance. I'm gonna close this out. Okay, just gonna minimize this. put it away. And oh, there we go. If I unlink this, there we go. So now I'm unlinked. This is the properly color calibrated. So I'm unlinked. This is PixInsight doesn't have to do anything here. This is how the Orion Nebula should look color-wise through, and we got nice filters for the club scope. So this is actually a pretty color accurate rendition of what the surrounding gases and stuff look like based off of all the stars that we used for a reference in here. So we got yellow stars, which are about right. You got some, you look at some of these, you got the brown dust down here. Oops. So, and that brings us to our next step. Our next demo part of this is noise. We got noise. You can see it here. It's just this brown stuff. Noise is down in here. We got noise here. You can see all these little pixelate. It looks like pixelation, but it is a noisy part of the image. It's just, you know, not enough exposure. That's basically what it boils down to. Richard probably could have gone another 20 hours to clean this up, which I highly encourage because I love exposure. But right here, there's no noise. So we don't really want to do noise reduction in this area. You don't see anything going on. Maybe a little bit right there. So what we're going to do is, what tool do we want to use? Use the usual one. Noise reduction. Multi-layer transformation. One of the most popular ones out there. Reset it. Reset is your friend. So the first thing we want to do is set up a mask for this. It's always the first step, usually in these things. It's right here. It's called linear mask. So we drop it down. One thing I want to bring up here is a lot of times these things do have previews. It's this little circular thing here, and we're going to have a preview right here. There's a preview. It's going to pop up. We got to actually click it, and it's going to bring up this little box for a preview. So this is the preview of the mask. We have it inverted, which is good. We can invert it. Now masking, that's kind of crazy. With masks, black means it's protected. That means whatever we're doing, whether it's deconvolution, convolution, whatever the process we're doing here, we're going to do noise reduction. So if it's black, no noise reduction is going to happen to it. If it's white, noise reduction is going to hit it full bore, 100%. Because this is a color image, that means somewhere between black and white, it's going to be some, somewhere in between, 50%, 60%, whatever. So if we go back and look at this, we know, like I said, I was kind of scanning around, these down in here, we don't want these super bright areas like where the star is. We don't need that in there. So what we do is we look at this amplification and we just kind of drag it. Oh, there we go. So you see how that grew? Now all this black area, so pretty much the entire Orion Nebula area, the main core, is going to be protected at this point. Do we need that much? I'm not really sure. It's kind of tweaking at this point. The amplification, as we go right, it's going to grow the area larger. I mean, we can go really far right. It might go too far. Nope, yep, too far. We don't want to. We want nothing to happen. That wouldn't be any good. And maybe that's too much. And then you notice sometimes, hey, there's maybe, it's not quite right. We want to smooth it out. If we do the smooth factor, it kind of smooths the edges and whatnot. We can take that to the right again. We can go to the right. Masks are some of the biggest mysteries I've seen people with PixInsight. Well, how do you get the right mask? How do you do this? And for me, for a long time, it was, exactly that. How do you do that? Remember, I was talking when I was zoomed in here. Well, this brown area is kind of, kind of a problem area. So looking here, here's the 3 stars. Here's the 3 stars. I want to hit this brown stuff over here. So, and I know I'm going to hit it because it's going to be right here. So I think this mask is pretty good. It's the nebula we don't want to hit. This bright blue area, that's fine. So I'm happy with this mask. So what we're gonna, oh, we don't want to lose that. So what we do is we turn off our linear mask. Oh, no, we want to turn on the linear mask, turn off the preview mask. There we go. Now the problem is we can't really see anything in here. It's too tiny. So down here, there's a little square button. You can say, hey, I want to see a preview of what's going on. So we can just drag a little box and it gives us a little preview area of what's going on. Let's see here. We can make this a little bigger. There we go. Hey, that's a little better. So next step is to actually turn on the what we want to do is turn on layers. So you can see here, actually, multi-layer transformation. There's two things. I'm sorry. There's two things. There's Starlit, multi-layer transformation. That's the actual tool we want to use. You turn on your noise reduction. This is since it's multi-scale, we want to have multiple ones turned on. So what we're going to do is just you want to go all the way down to 4 to start with. They're going to go all the way down. And as you see, as we went on down the list, hey, this thing got really smooth really quick. If you look here, the amount is, if we turned them off, we go back and you turn them off and you turn them off. And it kind of walks your way back. See how there's, if you look at it, there's little, I don't know if you guys could see that. Get even closer. There's noisy. So if we turn this one on, it just got a little bit less noisy. You turn this one on and it just got a little bit less noisy. Remember, this is color data. Now what's happening up here, nothing's being touched over here because our mask isn't messing it up. If we didn't have our mask on, this would start looking like mush. This would be, we'd be losing the smoothness here. It would take the smooth and make it even more smoother. Over here is what we don't, this is where we wanted to be getting fixed. So, and we have other tools available. We're doing noise reduction full amount. Maybe it's a little bit too much. So we can you know, draw it back so you can see, okay, actually you can't see my finger pointing at it, but we went from 0 to a full amount. There, nice little delay. The other thing is the threshold. We can dial that back a little bit. Sometimes you can do more than 4. You can go to 6 layers. Crank those on. Hold on a second. Like I said, a lot of times it's experimentation. We can turn on the 4th layer. The more layers you turn on, the more you kind of got dial stuff back. Well, this one has 0.4, and that's fine. This one's actually looking pretty good. You might have 6 layers, but until you actually turn them on, they're not doing anything. You can see they're on right now, but they're not doing anything. This actually looks pretty good. It's doing what we need it to do, I think. This looks pretty good. Remember, the color, the RGB, because this is an Lrgb image, the color is just going to provide the color data. So that's a good image. That's one thing you got to remember. Lrgb is this is going to be a good image in the end. So we're going to throw this on there. Sometimes RGB imaging is good. I mean, you could, this would be, I tell you what, back in the 90s, I know some of you guys have been imaging since then. This would have been a killer wall hanger back. I would have loved to have this back then. So this is all done now. So now we can go back and look. And now look at this. We got nice, smooth brown. This stuff really worked out nice. We didn't really destroy our stars. This brown area is good. This data is really well maintained. The blue areas are really good. So we got some really good stuff going on here. But this is all blown out still. Not really super crazy about that. But one problem we have is this is all linear data still. Remember how I said, hey, you know, what's going on? Our truth is, actually, this says image 11. That's not really intuitive. There's a thing here. If you right click this little tab, it says identifier. You can rename it. We'll call it RGB so it makes sense. So it's all over here. You can't tell what it is. So if we hit that, and then we actually hit your There, now we can see this. There's, you know, that's not too bad. It looks actually pretty decent. So we could do one of two things at this point. We could say, hey, we trust the screen transfer function. This does pretty good. Typically, I don't do that. I'll do a histogram transformation. So what that means is you actually turn on your screen preview. Oops, that's great. What did I do? Oh, that's right. I dragged it up. So we got a preview. So histogram transformation, you can stretch it. So this middle one, so you got your right here. You see how your preview is like stretching? You guys are probably used to stretching your, like in Photoshop or GIMP, or if you have PixInsight, you can drag your stuff, and then that's, you know, you got, that's your high end, your brightness. You can do the middle, and that brings it out. And then your far left is your blacks. That handles, that does all your clipping. So what you want to do with this tool, this is probably one of the more powerful ones, is just drag that one over. You can see it gets pulled up. And you could do that, drop it in there. And what you want to do is you want to kind of sneak up on it. See, your preview is all blown out now, so that's not cool. Do it again. So you want to drag it up. And then, hey, it's kind of blown out. So you take your left one and you want to drag it over, but you don't want to go too far. You can see the background starting to pull in there. And what I try to do is you look at, if you look at this red here, it's kind of shorty here. You never want this on this top graph. You never want to crash into this left wall, because that's where you start what's called clipping the data. You start losing stuff. Your background becomes too black. So we can throw that in there. And then you can really start to see stuff get going. Now, we don't want to go too nutso with this, because we still got to do our L, add the L in there. And that's kind of the mystery stuff. And we could keep going back and forth with this. But like I said, we still got the L to deal with. So what I'm going to do is actually, because I've been through this, I just wanted to show how this histogram, how you can sneak up on there and you're starting to get the background in. I'm going to actually go back to, okay, there we go. Okay. I am actually going to just use this. Okay. Now we got a stretched out image. That should be pretty good. We'll find out. So to do an Lrgb combined, we got the RGB. We actually want to do the Lrgb. There is a tool, and it's called Lrgb Combined. So it's right here, Lrgb Combined. Scoot this over. So it's a real easy tool to use. Just uncheck your RGB, because what we're doing is we're going to take our L, which is this guy, the HDR, name of the file, that's the one we want to look for. Click our little box, drop down, look for HDR, hit OK. So it's in there, it's checked. This stuff, it doesn't matter at this point. None of this stuff really. I would say that's more advanced tweaking stuff. Most people don't even mess with this. So, and then we take this box and we just drag it in. You can see what it looks like. And it's combining for us the L in there. Now, you could, if you, this is luminance data, you could throw in H alpha data if you wanted to. That is totally possible. So actually, yeah, that went pretty quick. So now here we got Lrgb data here. So let's see, where are we? Okay. So now at this point, we got some Lrgb data. We're getting close to the end here. At this point, what I would be doing is starting to close in on final tweaks. We got really good color data. Unfortunately, like I said, the core's blown out. There is some funkiness. I won't say funkiness, but overall, I'm pretty happy with it. The background isn't super bright, but we're going to start taking care of that real quick here. What we can do is do our screen transfer function. That helps brighten it up real quick. That's a quick win that we could do. And what we can do, like I said, we can undo it, do a quick win. That helps brighten it up, helps contrast. So we can do a quick reset that, drag this down, and boost that real quick. Now look at some of the detail we got here. So now we got a good brightness going there. We look here, we got a good sharp color contrast. Now it becomes a tweaking game. This is where personal preferences really start to come in. And there's a lot of tools at our disposal. We got the histogram transformation. What you can do, obviously, you would be working from here, from your preview, you would be, working on either your, your midpoints, keeping that your darks adjusted to some extent. Another tool that you would be wanting to play with is if you go down in here, you got your curve transformations. A few different areas. You have your RGBK. This is like the overall curves. I mean, once again, you'll want to, obviously you got your reset here, you got your preview. So a really cool part of these tools, same thing with the histogram transformation. If you take your little cross and you click on it, look at the curve transformation and the histogram. You see the lines in there? It's showing you exactly what's going on in the background. So for the actual background for where I am, you can see exactly where. So if you want to lock the background, say, hey, I want to keep my background that color or that darkness, you can see right where to put a lock. So for like the curve transformation, I want to keep that darkness to be around there. So I can go, okay, I want to keep my darkness around there, but I want to brighten everything else up. Or my core really shouldn't get much brighter. So you can see where my core is. That's where my core brightness is currently at, is that part of the curve. So right about there is where I need to deal with it. So I need to bump this up a little bit. So I can, now, like I said, it's a really delicate, because you can go crazy. Hey, that looks like garbage. People, it wouldn't look good. Or you go drag down. You can do stuff that doesn't look good. And that's where it starts getting trickier and trickier. Let me reset this real quick. But you can play around with it as far as, like, for instance, that's your colors. Now you can do saturation. That's a popular one. Saturation, you got to be, that's going to deal with, like, how reds are the reds, how green are the greens. I like little boosts. Again, it becomes personal preferences. So I'll throw that in there. And you'll see the reds will start getting a little more of a boost. And you see your preview. You get a little bit more in there. We could throw another one in there. It becomes, how far do you go? He starts becoming more from science to whatever, artistic interpretation. We did start with the photo color calibration or correction, which was really true color, to, you're starting to highlight it, it starts becoming more. And I think there's a good balance here, because you got your dust, it's starting to become brown. You got your reflection nebula, you got your red stuff. I mean, that's the technical term, I guess. Any questions? I mean, there's so many tools I could cover. I mean, there's contrast enhancements that you can do. I'm just trying to think of what was the tool. This is the version I came up with Richard. Where is it? I don't know how close I got to it. Oh yeah, that's the one I came up with. And this is what I just came up with. You can see that the differences are, I mean, these are two different paths I came up with. This one was a slightly different take on it. I want more with more of highlighting, maybe some more of the H alpha tinge to it. I think this one, the one on the left, is more color accurate as far as the dust and stuff. This one has more of the H alpha look to it. I think the left one's more accurate. I don't know.
Pete, have you worked with, because obviously this is a very star-rich image.
Mm-hmm.
There's some of the morphological transformation tools, things to do a little bit of kind of de-emphasize the star background. Have you worked much with that?
Yeah, I have. I have worked with, where is it? This one right here. Yeah, I worked with this actual image with the, oh, actually I did not. Yeah, I did use morphological, where I de-emphasized, because this field actually was pretty big and I just wanted to emphasize M93. And so what I did is I actually did a range select. I used a range select tool to actually get my I used range select, and then I blotted out. I got my range select down and then got the rest of the stars out. So I preserved just the main cluster of M93. And then I used the morphological to squeeze down the stars just a touch bit. I mean, just to kind of emphasize it. And I eroded the stars. So when I actually used the, where is it? Morphological transformation, it really did work out really well. And I started using that mostly with the clusters because that seemed to be the issue. On something like this star rich, I haven't had the chance because I'm using an 8-inch Ritchie for the most part. So I don't run into such a rich star field like this. So this was a good challenge for me, actually. And I'm hoping to actually add a wide field scope, a more wide field. Actually, I have an 8-inch f4 Newtonian that's sitting up here on the shelf, but so
does range selection help you set a mask for the, is that what it's protecting, or is that what it's actually going to transform? So combination of range selection and the morphological transformation?
Yeah.
Are those the two tools together that you're using?
Yeah, exactly. Yeah, I'll use the range selection to actually, I'll use the range selection to kind of get it down to just the stars themselves. And then yeah, let me pull that back up a second. Oh, that's the JPEG. Oh. Oh, you know what? I didn't even talk about projects. PixInsight does have a thing called projects, which is a great way to, I actually save everything as a project. And when you, I won't open it.
Started in another workspace.
Yeah. Yep. Yeah, let me just switch over.
I get over. Yep. There you go.
Yep.
No.
No.
That doesn't sound right.
Yeah, no.
How about load project? Is that what you were doing?
Yeah, that's what I was doing. Usually
so a project contains, well, okay, so just describe it. So the project contains all of the...
the project contains everything about what I'm working on, all the images, the entire process history, the whole everything, all the workspaces for my project. So I'll use, like when I'm processing like a complete galaxy, sometimes I'll throw like my H alpha processing, my Lrgb, I'll split stuff out to different workspaces. So my luminescence is one workspace, my RGB is in another, H alpha sitting in another, just so I can keep things kind of.
So it preserves all your workspaces. That's why when you said open, it said, do you want to delete? Because it was going to wipe out everything that's in your workspace one,
right,
with everything that was in that project.
Right.
So, yeah. Okay.
Yeah. So anyway, yeah. So basically, I will either range select or I'll use even the well, I'll do a range select just to pick the stars out, and then I'll create the mask, and then I'll use the clone tool with a supersize and actually wipe out the rest of the, the periphery of like, especially for like that particular cluster. I'll wipe out the whole, most of it. And then I'll do the morphological transformation on there just to shrink them down to do the erosion. And that's worked out. Or actually I'll do the inverse, honestly, because in that case, I want to protect the cluster itself. I'm trying to shrink down all the stuff around it, honestly. Right. So I'll do the range select to pick the stars of the cluster, and then that's the protection, and then I'll just yeah. So actually on this one, if I actually did do it, I don't even know what it would look like. Oh wow, that's a huge mess. Anyway, so yeah. I'm surprised that worked. So yeah, so I would do trying to see how I can get that. Yep, so I would do this. So I messed that up.
Right.
Yeah. Yeah.
Okay.
Sorry, I was just thinking.
Yeah, you're wanting to protect the cluster, and then
then I blot out
everything that's outside of that. Okay.
Yeah, and then I would do the reverse on that.
Okay. Yeah, because I love taking shots of clusters. That just some of them I just get too noisy. There's too much going on. So.
Yeah.
Good idea.
Yeah, and then at that point I would just get the clone tool out and just set it to a really big clone.
Yeah, that's an interesting. Yeah.
Yep. Yeah, set it up to a whatever. You just set up set up like a 100 size or whatever, and then I just kind of do all your wipe it around. Oh, I made a mess of that one. Yeah. But yeah, then I did that, and then I shrunk it down. But then I also saw that I've seen a few different ways. I'm gonna close that off. It seemed to work out pretty well.
Yeah. Okay, give it a try.
Yeah.
Thanks.
Yep. Anyone else? Any questions? For those wondering, let me see here. PixInsight is 230 euros right now, which is 278 US dollars. In case anyone wondered that, I did the conversion. They do have like a 75-day trial currently, if it's a thing. Like I said, there's other tools out there, but PixInsight is a pretty popular one. And even for members who have who are using the remote telescope and stuff, I'd be happy to, help process data that you've collected, or even other members, with the SIG group, we can do group processing too, to help you out if you do get PixInsight and you get stuck and just can't figure it out or whatever. Do stuff like this. I mean, that's the whole idea for the group that's forming. So.
Can the group answer this? I mean, after you've spent, like I have on my rig, after you've spent, umpteen, it's 5,000, let's say as a starting point, on all your equipment, you won't spend the $350 for PixInsight, which is a killer, program.
Oh, I know.
Where is the logic? It's just like, someone explain that to me, please. I'm missing the point.
Yeah. Yeah. I've had this now for, I don't know how many years. It's paid itself over so many times.
And PixInsight, unlike a lot of the software companies, is still, you buy it once and you've got it for good. They send out updates about, once a quarter. Already yep. I see, it's been 6 months since I logged in and I already see changes to dialogues. So, and they keep incrementing it. And you don't have to pay $300 every year for it. You pay,
Oh yeah.
It's one time.
It's a
good tool. Great price.
Yeah, it's an excellent tool. There's there's like stuff like this annotation tool they have. It's just phenomenal. It'll go through and annotate your image. So point out all this. It doesn't get everything. I mean, there's some really tiny stuff like this object. There's some really tiny stuff that's not in there, but the stuff that's on there, the forums that you can ask. I mean, there's definitely stuff in here that are good luck trying to figure it out. I mean, there's some really advanced stuff. Like I said, some of the stuff is there's a lot of options in here that are, you know, like, hey, what does this particular box do? Not necessarily in here, but, you know, like the difference between median transform and median wavelet, there's some fine differences, or, you know, some of the other tools. The core set of tools, I use a lot of the same tools and they get me some really good results. But they've got me pretty good. I finally, AstroBin, if you look at a lot of pictures on AstroBin, they've all been pretty much processed with PixInsight. There's a picture. Huh. So, I don't know what else to say. It's a pretty good. Where else is it? Yeah. Yeah, that was my first top image of the day, or one of my top images. I mean, so it's really good software. Actually this one did have a lot of satellites through it, but the noise reduction, phenomenal. I mean, there's like next to nothing in here, but but yeah, Richard, you had phenomenal data here. It's some really good stuff, minus the satellites that snuck through.
Quite a few of them. Yeah.
Outside, like I said, outside the little bit of the goofiness in the corner here, this is a wall hanger. I mean, even from a distance, you really don't notice the stars. Just the nebulosity is pretty impressive.
All right. Anything else, Pete?
No, I mean, I don't know. I mean, it's really up to if anyone has any specific questions. I mean, the workflow is very similar. If you have a one-shot color camera, instead of dealing with individual channels, you load up your one-shot color. You still deal with, you know, flat frames and dark frames. You could do bias if you want. There's, you know, you still load them up. You still do color calibration, stuff like that. You could extract the colors. I've seen people do that. I mean, there's a lot of ways, but it's still very similar. You can process DSLR camera stuff. When I have a Nikon, I do process Nikon pictures in here. So it can handle a whole range, and like you know, was asked earlier, can it handle JPEGs? Yeah, you can throw all sorts of stuff in here. It'll process them.
Thank you.
All right, great. Well, thanks, Pete. And just another reminder, we're just getting started. Don't forget, you can register now for our first astrophotography SIG meeting. Again, that's on Friday, May 21st, I believe, at 7 o'clock. And the first meeting will, again, just kind of be setting up the future. So again, be sure you join us. And Pete, thanks again.
You're welcome. Yep. Thanks, everyone.
You.